today should be short because I only have one more problem to do, and then we're going to call it a day, actually. Okay, so let's knock out this last problem. I'm going to go ahead and draw a box, and I'm going to write down, oops, draw my box this way. And then I'm going to write down P is equal to V is equal to N is equal to T is equal to. And somewhere if I'm doodling problems like we do in chemistry, I will go P, V is equal to N, R, T. Just kind of, even before I've looked at the problem. Because it looks like a gas law problem. If it looks like a duck and quacks like a duck, walks like a duck, probably is a duck. Okay. So it says what volume, so I'm going to find V and I'm going to put question mark, what volume will 0.20 grams of carbon dioxide. Now, at this level, we usually don't give you information. Sometimes temperatures you're given and you don't use them, but you're going to have to use that mass somewhere, 0.20 grams of carbon dioxide. And actually, I'm going to use it right here with my number of moles, okay? We've talked a lot in here where we can go from 0.20 grams of CO2, we can go to moles using the molar mass. And that's exactly what we're going to do. Occupies a pressure of 732 millimeters of mercury. So pressure 732 mmHg. But we talked the other day, since R has units of atmospheres, liters per mole, Kelvin, then actually these 4 units set what these units need to be. I mention that because our pressure is in millimeters of mercury. We're going to have to go to atmospheres, ATM, and we're going to have to use, and you might want to put this on your note card, 1 atmosphere is exactly equal to 760 millimeters of mercury with regard to pressure. So we're going to have to do that conversion. And then it gives me a temperature of 22.0 degrees Celsius. So I'll put that where my T is. I'll put 22.0 degrees Celsius, but I need to get it to Kelvin. So I'm going to put arrow Kelvin. And I do that by, by adding 273.15 units. So that's kind of what we got going on there. So question mark volume, I have a P, an N, and a T ultimately. So there are different values for R. If you stay in physical sciences, you'll find that out. But the one that we're going to use for gas law problems, and has the specific units of liters, atmospheres per mole Kelvin, has a value of 0.082058. Whoops, 0.082058. All right, so when we're done, what this slide is saying is the volume will be in liters after we make these corrections. So even though it's one problem, we have kind of some front-end things we got to do. So we'll do those front-end things. So, but before we do that, let's go ahead and isolate volume by itself. And we can isolate volume by itself by dividing both sides by P. Okay, so it looks like this. Volume is equal to nRT over P. Not too bad. Now let's start fixing the terms we need to fix. So we're going to go from that 0.20 grams of CO2 to moles of CO2 using the molar mass of CO2. So the molar mass of CO2 in the periodic table looks like this. We take 1 times the mass, molar mass of carbon, 12.01, plus 2 times how much the oxygens weigh, 16.00. So our molar mass is 44.01 grams per mole. So we've done these, seems like, for the last couple of units. We'll start with the mass of CO2, 0.20 grams over 1. And then we want grams to cancel, so we're going to use what? The flipped version of the molar mass. So it'll be 1 mole of CO2, or just 1 mole over 44.01 grams. Grams cancel, we're left with moles, rounded two significant figures. That N value in our equation is 0.0045 moles. Okay, that works. Here's fixing the temperature. So we need to take our Celsius temperature, 22.0, and add 273.15. We round according to decimals. So we have 1 decimal in our Celsius temperature. So it's 295.2 Kelvin. 295.2 Kelvin. And then last but not least, we have to fix those millimeters of mercury, mmHg, to atmospheres. So we take the 732 millimeters of mercury over 1 times 1 atmosphere over 760 millimeters of mercury. So remember, that's an exact relationship. Our millimeters of mercury will cancel. We're left with units of atmospheres. Round to 3 significant figures. I got 0.963 atmospheres. So now, finally, we have our 3 quantities to plug in and get volume. So it looks like this. So there's our ideal gas law equation rearranged to solve for volume. So in the top, in the numerator, we have 0.0045 moles times 0.082058, and the units of R are liters, atmospheres per mole Kelvin, times the temperature in units of Kelvin was at 295.2 Kelvin, divided by the pressure, which was 0.963 atmospheres. And this semester we've been all about making sure our units cancel. So let's check that out. Moles cancel, okay. Units of Kelvin cancel. Units of atmosphere cancel, and we're left with units of liters, which is wonderful. So it looks like we need to round according to 2 significant figures, and our units will be in liters. So we get 0.11 liters. Not bad. So on your test, you will see, I think it's a multiple choice question, like a gas law problem. So now at the end of the test is going to be workout problems, and that's not where the gas law problem is. I don't think, not for you guys. Okay? So these are going to be, and some of you totally don't need these extra credit points, but if you bring them when you come to take your test on Monday, you can get 10 extra credit points. So they're optional. They look, I'll take a look at them right quick. They look just like what we've been doing in class, the examples. Okay, so here they are. So for instance, the first one, 59, is after volume. So you're going to use the exact same form of the ideal gas law equation we used. And notice in this case, you don't even have to go from grams to moles. They give it to you. And you don't have to fix pressure. It's in atmospheres. And you don't have to fix temperature in Kelvin. So 59 is easier than what we just did. 61 is your after N. How many moles of gas are in the cylinder? Okay. Given the temperature, the pressure, and the volume. Then 64, what's the pressure in millimeters of mercury, given those moles, this volume, and this temperature. So when I'm looking at 64, I'm thinking the only thing you need to fix is the milliliters to liters and the Celsius to Kelvin. But just plug in. So they're kind of fun. They wouldn't be too bad. Okay? So it's just totally optional. So that's all I have, unless you guys have any questions. I'll try to be in my office like at least an hour before class on Monday in case you have any last minute questions. But okay? Going for the A's. All right.